Imagine looking up at the night sky, so many stars. Out there, just a stone's throw away in cosmic terms, lies a planet. It's called Proxima Centauri b. It orbits the closest star to our sun, Proxima Centauri. This makes it our nearest known exoplanetary neighbor. Think about that. A whole other world, tantalizingly close, yet so far. It whispers of possibilities, of new frontiers. It beckons us, humanity, to look beyond our cradle, Earth. Proxima b is more than just a scientific curiosity. It represents a dream. The dream of interstellar travel, the dream of finding other Earths. Could there be life? Could humans one day walk its surface? This small planet, likely a bit more massive than Earth, holds a special place in our quest to understand the universe. It's a beacon for future explorers, a target for our boldest ambitions. The significance of Proxima Centauri b cannot be overstated. For millennia, we've wondered if we are alone. Exoplanets were once just theoretical concepts, figments of scientific reasoning. Now we know thousands of them. How do you find a planet so far away? You can't just see it. Proxima Centauri b was a ghost in the data for a while. Astronomers use something called the radial velocity method. Think of a star and a planet dancing. The star isn't perfectly still. The planet's gravity makes the star wobble, just a tiny bit. This wobble changes the color of the starlight we see. A slight shift towards blue, then towards red, a cosmic heartbeat. Detecting this subtle shift is how Proxima b revealed itself. The official announcement came in August 2016. Big news. Scientists at the European Southern Observatory were thrilled. They used the HARPS instrument on a telescope in Chile. The project was called Pale Red Dot, a nod to Carl Sagan. For months they meticulously gathered data, checking every detail. The evidence mounted. The star Proxima Centauri was indeed wobbling. And the cause? A planet, at least 1.3 times the mass of Earth. This discovery electrified the world, astronomers and public alike. So, Proxima b is close. But what does close mean in space? It's about 4.24 light-years away. Light itself takes over 4 years to get there. Our fastest spacecraft, like NASA's Parker Solar Probe, are incredibly speedy. But even at those speeds, the journey would take tens of thousands of years. Think about that, thousands of generations living and dying on a spaceship. That's a challenge of an entirely different scale than going to Mars. The sheer distance is mind-boggling. We need a revolution in propulsion technology. Current chemical rockets just won't cut it for interstellar travel. Then there's the radiation. Space is not a friendly place. Our sun protects us with its magnetic field. Earth does too. But out in interstellar space, it's a shooting gallery. Cosmic rays, high-energy particles from distant supernovae zip everywhere. They can damage spacecraft systems and are incredibly harmful to humans. And Proxima Centauri itself is a red dwarf star. These stars are known for powerful, unpredictable stellar flares. Imagine arriving after a multi-millennia journey only to be zapped. Shielding would need to be incredibly robust and very heavy. Beyond radiation, there are other physical hazards to consider. So, what would an astronaut find if they landed on Proxima b? We don't have pictures yet, just data and educated guesses. The planet is likely tidally locked to its star. One side would permanently face the dim red glow of Proxima Centauri. The other side would be trapped in eternal darkness and frigid cold. Imagine a world with a day side that never ends, and a night side that's always night. This creates extreme temperature differences. The Terminator Zone, the twilight strip between these two extremes, might offer more moderate temperatures if an atmosphere exists to spread heat. But moderate is a relative term on an alien world. The star itself, Proxima Centauri, is a major concern. Red dwarfs, as I mentioned, are flare stars. They can unleash sudden, intense bursts of X-rays and ultraviolet radiation. These flares could be hundreds, even thousands of times stronger than our sun's. If Proxima b doesn't have a strong global magnetic field like Earth's, this radiation would bombard the surface relentlessly. It could strip away any atmosphere the planet might have. It would certainly make the surface incredibly hostile to life as we know it. Any human explorers would need serious protection, underground habitats perhaps. Section 5. Can we call it home? The question of habitability. The term habitable zone can be a bit misleading. It simply means the region around a star where a planet have liquid water, if it has sufficient atmospheric pressure, and if water is present. Proxima b orbits squarely within its star's habitable zone. That's good news. This zone is much closer to a dim red dwarf like Proxima Centauri than it is for a bright star like our sun. so Proxima b zips around its star in just about 11 Earth days. But being in the zone doesn't guarantee habitability. Not at all. It's just one ingredient in a very complex recipe for life. We've touched on the challenges: radiation, tidal locking, atmospheric stripping. These are significant hurdles for life as we understand it. The intense flares from Proxima Centauri are a major problem. Could life evolve under such a barrage of radiation? Perhaps. Life is tenacious. It might find a way, maybe underground or underwater if liquid water exists there. Section 6, Bridging the Void, our evolving spacefaring tools. Our current rockets are amazing feats of engineering. They've taken us to the moon, to Mars, and sent probes to the outer solar system. The Voyager probes, launched in the 1970s, are now in interstellar space. But they are incredibly slow by interstellar standards. They would take about 75,000 years to reach Proxima Centauri. Clearly, we need something much, much faster. Chemical rockets, which burn fuel, have fundamental limits. You need to carry all your fuel with you, which makes the ship heavy. It's like trying to cross an ocean in a rowboat with a limited supply of sandwiches. So, what are the alternatives? Scientists are dreaming big. One idea is solar sails, or more accurately, laser sails. Imagine a giant, ultra-thin sail pushed by powerful lasers from Earth. This could accelerate a small probe to a significant fraction of light speed. Projects like Breakthrough Starshot are exploring this very concept for Proxima b. Then, there are fusion rockets, harnessing the power of nuclear fusion, the same process that powers the sun. This could provide much more thrust. And for the far future, perhaps antimatter engines. When matter meets antimatter, they annihilate, releasing enormous energy. Section 7. Painting New Worlds. Terraforming and Intelligent Exploration. What if Proxima b is harsh, but we still want to go? This brings us to a truly grand and controversial idea: terraforming. Terraforming means transforming an alien planet to make it Earth-like, giving it a breathable atmosphere, stable temperatures, liquid water, essentially creating a new home for humanity among the stars. Imagine seeding Proxima b's atmosphere with engineered microbes, or building giant orbital mirrors to warm its surface or shield it. These are concepts straight out of science fiction, but scientists think about them. It's the ultimate planetary engineering project. The scale of terraforming is almost unimaginable. It would take centuries, more likely millennia if it's possible at all. Think about the energy required, the resources, the scientific understanding. We are still learning how Earth's own climate system works. Attempting to fine-tune another planet's environment is a monumental task, and there are ethical questions. If Proxima b has its own native, perhaps microbial life, do we have the right to change its environment to suit us? This is a debate we'll need to have as our capabilities grow. Section 8. The Unquenchable Spark, humanity's drive to explore. Why even bother with all this? The cost, the difficulty, the danger. Why reach for Proxima Centauri b or any star? The answer lies deep within us. It's an unquenchable spark. Human history is a story of exploration, of pushing boundaries, from the first hominids venturing out of Africa, to ancient mariners sailing uncharted seas, to astronauts touching the moon. We are driven to see what's over the next hill, beyond the horizon. It's in our DNA, this restless curiosity. The cosmos is the ultimate uncharted territory. This drive isn't just about adventure, it's about knowledge. Every new world we study teaches us more about our own planet, Earth. It helps us understand how planets form, how climates work, and of course it addresses that fundamental question: are we alone? Finding life, even simple microbial life, on Proxima b would be one of the most profound discoveries in human history. It would change our perspective on our place in the universe forever. Science thrives on new data, new mysteries to solve. Section 9. Our future among the stars. A cosmic destiny awaits. Proxima Centauri b is more than just a point of light, a wobble in data. It is a symbol of what humanity could achieve. It represents a tangible goal for our interstellar aspirations. Landing a human on Proxima b or even sending advanced probes would mark a new era in our cosmic journey. It would be a testament to our species' ability to overcome obstacles, to turn science fiction into scientific fact. Think about the moment our descendants might look back at Earth from the surface of a planet orbiting another star. What a thought! The universe is vast and our journey is just beginning. I want you to look up at the night sky, feel the immensity, and remember that around the very closest star there's a world. It might be harsh, it might be alien, but it's there. And it reminds us that there are countless other worlds out there. Billions of stars in our galaxy alone, many with their own planets. What wonders await us? What will we discover? The future of humanity is inextricably linked to the cosmos. Whether we explore it with robots or one day with our own footsteps, the stars are calling to us. This journey, this grand ambition will require patience.